So hello guys, in today's video we're gonna find out center of gravity of some difficult looking section in a very lucid way. Finding center of gravity of T, I and C section is very easy, but sometimes we face problem when it comes to an unorthodox figure. So in today's video we're gonna find out center of gravity. So the first problem is a square hole is punched out of a circular lamina and the diagonal of the square being the radius of the circle as shown in the figure. Find the center of gravity. So this is the circular lamina and the square hole is punched out from the circular lamina and the radius of the circle is r and the diagonal of the square is, as mentioned in the question, is r. Another diagonal of the square will again be r, just because it's a square section and it's a cut hole section, and because of that the formula of CG will be a1 x1 minus a2 x2 by a1 minus a2. So the section 1 and section 2. So first we need to find out the area of the section 1, which is pi r square, just because it's a circular section, and the distance of center of the section from y-axis is denoted as x1. So I take x-axis at the bottom position and y-axis at the extreme left position, but if you want to take x-axis and y-axis in any other position based on your convenience, you can. So first, the distance of y-axis from the center of the section is r. I can easily see that. Okay, so this is r, and for the second section, section 2, and as the diagonal is r, another diagonal of the square again will be r, so r into r by 2, this is 0.5 r square, and x2 is somewhere here. So x2 is the distance of y-axis from the center of the section. So the distance of y-axis from the center of section will be r plus, it will be r by 2. Okay, so r plus r by 2, this is 1.5 r, and if I put the values of a1 x1 a2 x2 in that position, it will be like pi r square into r minus 0.5 r square into 1.5 r by pi r square minus 0.5 r square. So if I simplify, I will get this. Okay, I will get this. This is the answer. So the problem is somewhere you may find it difficult looking, but it's a very easy problem and you can easily find out the solution of this sort of problems. This is the second problem. In the second problem we have a trapezium section and we cut a hole, semicircular hole from the trapezium section, and all the dimensional mentioned in the figure, and I considered x-axis in the bottom position and y-axis in the extreme left position, but if you want to change the position of x-axis and y-axis based on your convenience, you can. And first of all, the section is symmetrical about y axis and the bottom length is equal to 300 millimeter. So as the section is symmetrical about y axis and distance of center of gravity of the cut hole section from the y axis will be 150 millimeter. This is 300 millimeter, this is half of 300 millimeter, this is 150 millimeter. But we don't know the center of gravity of the cut hole section from x-axis. So we need to find out the center of gravity of cut hole section from x-axis, and for cut hole section we use the formula that is y bar is equal to a1 y1 minus a2 y2 by a1 minus a2. So a1 for section 1 and y1 for section 1, at the same time a2 and y2 for section 2. So a1 area of the trapezium is a plus b by 2, a is 200 millimeter, b is 300 millimeter, a plus b by 2 into h. So if I put the formula, if I put the values in the formula, I will get 3000 millimeter square. And y1 is distance of center of gravity of trapezium section from y-axis. Distance of center of gravity of trapezium section from y-axis, and the general formula is 2a plus b by 3 into a plus b by h. Okay, so you need to remember this formula, and whenever you find a trapezium section and you want to find the CG of the trapezium section from x-axis, you can use that formula. And after putting the values in the formula, I'm getting 56. For the section 2, the area is very simple, that is half pi r square, and for y2 it means center of gravity of a semicircular section, and distance of center of gravity of a semicircular section, this might be somewhere here, and that from y-axis. So I need to find out this distance, and the general formula we use is 4r by 3 pi. And whenever you find a semicircular section, you can use this formula to find out the center of gravity of a semicircular section. Okay, this is the distance, again this is the distance of x-axis and the center of gravity of a semicircular section, this one. Okay, so if I put the values in the formula, I'm going to get a value 120 by pi, and if I put the values in this formula, I'm going to get 61.9, that is the y bar. Y bar means, as I already told you, distance from x-axis. So distance from x-axis, y bar equals to 61.9, somewhere here, and as section is symmetrical about y-axis, it means the distance from y-axis, distance from y-axis is equal 150 millimeter. So that's it for today. If you want more videos and if you have any confusion regarding these problems, you can comment below, and please do subscribe